So now how do we spread the trunk pieces along the path the correct amount of times? So we know that it needs to happen, a number of times. So I'm going to control drag that out. We're going to need that for sure. We're also going to need the path in reference to it, because we're going to have to find out, what point along the path, where is that in space? Okay, wherever, if we follow that path along. Okay, and we're going to have to track that by the amount of them. So one, how do you get a point along a spline? So we're going to say get location at distance along spline. So get location at distance along spline. So what is that doing for us? It is grabbing the target, so it's our path, and at some distance along it, it is going to return a vector value for us that is going to be able to drive our location here. So it's going to be able to, give us that location value. Now, to be able to do that, we're going to have to loop through the amount of trunk pieces that we're working with. So we know that we need to loop through this many times. So instead of just plugging this directly into the crate instance, I'm going to pull that out and I'm going to look for a for loop. Now, for loop is a little mechanism that is going to run this n amount of times, and that n amount of times is going to be the number of trunk pieces. Loops start at a value of 0. The first one's 0. The last one is really going to be the amount that we need minus 1. So if we needed 1, we need to loop from 0 to 0. So if the amount of this value was 1, we can't plug it in directly. We're just going to put in a subtract, and it's going to always subtract 1 from it. And that'll loop the correct amount of times now. So it's going to start at 0, and it's going to loop this amount of times. Now this should then print that amount, or in this case, it's going to create, we said it was going to create 8 of them. It's going to create 8 instances, but they're all going to be on top of each other. So, where are we going to be looking for that point on the spline? How do we know where we're going to be on that distance? Well, we know we have the height of each piece, and we have the index of the loop here is being returned. And this is going to return a value. If there was 8 pieces, it's going to start at 0. It's going to return 0, 1, 2, 3, 4, 5, 6, 7. Each time it runs, it'll increment up. So if we take the height of each piece and we multiply it by the increment, we'll start at 0, and it'll move it along. So we'll be able to get that distance along the spline, okay, for each one of these items here. So I'm just going to drag out. I'm going to hit the multiply again, and we're going to multiply these two together, and then we're going to plug that into the distance, and we'll plug that into the transform. So this is going to get that distance along the spline with this. So I'm going to say compile, make sure I save, and we're going to go back, and now you're going to see we actually have it, dragged out here. So I've moved things around by mistake. So I'm just going to go back and just hit escape and then select the whole thing and re-drag it out. And you'll see that it's projecting it up. As I make this longer, you'll see that it is adding more or less of them with a gap at the top until there's room for the next. That should be okay, really, for our purposes here. We're going to have a big tree sticking out of the top of it, all the leaves and everything. But, you could go one more effectively and always have it fill that end bit if you wanted. Many ways you could handle that. But now you can see that goes up and down. If I actually pull it over sideways, or I go in and rotate this, you'll notice that it is rotating into place. But what you'll also notice is that its rotation isn't following the spline. So it's not following that curve like we're going to need. So we are also going to have to control the rotation value along that instance, and we're going to have to know how it is rotated as we go. So the next one we need is something called get tangent for the path. So I'm going to drag down, and it'll be get tangent at distance along spline. So the tangent at, where is it? Get tangent at distance along spline. So the tangent is the direction that it points along its length, and it returns a vector value as well. So what does a vector value look like? Well, you can think of it as this, XYZ handle that you would have, and it's returning a point at each one of the tips. So it's a vector as to where this thing points and how it orientates along the length as it's moving along the spline. So this is not a rotation value. It's not going to allow us to do that. If we drag and drop it, it's going to say rotation from X vector. And so what it's doing is it's taking one of the vectors pointing out of that X, Y, and Z, and it's turning it into a rotation. Okay, and if I say compile, you'll now notice that they are rotating along the length, but not the way we want. Okay, so what we really want is a rotation from, so we'll say rotation from Z-axis should get it. So because we want it pointing up along the length, okay? And that's the one, that's sort of the dominant one we want, is the fact that the piece points up in 3ds Max when we exported it, and made sure that transforms were reset or anything. And now that we have that working, that should now point it up along the length. So you can see that those pieces are starting to point, but they are not going at the right distances. There we go. It was all getting it from the bottom. So I missed that, and now there you go. It is now pointing up along the length, and as I rotate that, you can see them. It's going to be pointing together. So we're also going to want to have some sort of offset so that we can push those together. We can cram them in closer together. So we have that distance along spline that we're controlling up top to be able to control how long basically the height of each piece is here. So let's make a parameter and let's control the height of the piece, sort of override it a little bit. We've got a unit of about 60. Let's do an add subtract from it. Now this is going to be a user parameter that we want to have the user be able to dial in so that they can cram them and overlap them. So under variables, not local this time, I'm going to hit the little plus sign, and we're going to make a variable. So maybe trunk height offset, and it'll be a float value because it could be 0.5 or whatever it might be. And we want it to be available and visible to the end user. So we're going to click that on. And then I'm going to drag that out, and we're going to take the height and we're going to add this value in. And if it's a negative value, it's obviously adding a negative value, which is going to subtract. I'm just going to save, compile, and go and pick it. And now you'll have this trunk height offset. And if I pull that down, you'll see that it is now deriving that. Now, the thing is that is driving it after we got the amount of pieces. So maybe this isn't the best spot to put it. I'm going to plug that back in. That's the trunk height. Why don't we put this, and I'm just going to say cut, and we're going to go back to our setup here and find out where we're setting the trunk height. And we're going to put that in here. And so we're going and getting the height value, and then we're going to set that height early on so that when we go and get the num trunk pieces, it already is using this variable, okay, that will be set correctly. So I'm going to say compile, and now you can see that it adds it in there. So as we increase or decrease that, you can see that those are being added or subtracted as needed. So that is allowing us to get the trunk on there. Now we might want to also work with the scale of these to make them narrower, essentially. And so we could work on that. And so there's the input scale value of each one of them. Let's just make it in the X and Y instead of the Z, and just make them thinner as they go up. And so we're going to call this the trunk scale. and I'm going to make it visible. And over here, you can see, please compile the blueprint. It's interesting because you can see I can set a default here. This one I can't set a default until you hit compile, and then we have that value. We're going to set it a value of 1 because scale is a value of 1 as a default. And then I'm going to drag that out, and I'm going to plug it directly in. It'll put a conversion node because we've got to go from a single float value to a vector value of X, Y, Z. Okay, that's going to control all of them though. So here's something neat. I'm Alt click and deselect that. Just get rid of that conversion. I'm going to right click on the scale and say split struct pin, and now I can control just the X and the Y and leave the Z as is. So I'm going to hit compile, and we're going to go back, and there's the trunk scale, and now you can see I can scale all of them at once. So that's an overall trunk scale. That's pretty good. You know, I can handle that. What if I wanted to be able to have it taper and get narrower as it went up? Well, we're going to have to do the same sort of thing. We're going to have to be using our loop, and we're going to be looping through, and we're going to be changing that result by some amount. So again, we're going to need a variable for the end user. Call it trunk taper, make it visible. I'm just going to hit compile again. And it's going to be a value of 0 to begin with. It's going to add or subtract onto it effectively. But it is going to be based on what loop we're on. So once again, we want to take that taper value and we want to multiply it by what iteration we're on. So 0 times 0 when we're on the first one is going to be 0. And then we can subtract this from this value or add on to this value. We'll do an add on to, so add, and we're going to choose add. We're going to add this on, and that's going to plug into those two. So we're going to override that one. So it's basically going to take the trunk taper, and it's going to multiply it by whatever iteration we're on, and we're going to be able to add or subtract to that scale as it goes up the value. So you can see now we can scale it nicely, which is really nice. Now this value is really touchy, and so let's just make it not so touchy. So there's the trunk taper. I'm going to multiply the trunk taper by some small value. I don't need it to be changeable, so I don't need a variable. 0.01, let's say, so that it is less touchy. I'm just going to save, compile, and now you can see it isn't as touchy. It takes us, we got to go all the way up higher value to be able to get it. You could, add one more 0 in there and make it even less touchy, but that works pretty good. So now we can taper our trunk, and we can compress it to the overall scale of it, and we can also get the offset, and you can see that it starts tapering too much, and we may have to taper that back out again. Okay, so not bad. It's it's getting there. It's got the trunk going. So let's talk about getting the leaves up on the top now.